In this video, we are going to convert from binary to octal and vice versa, and the binary to hexa and vice versa directly. We are not going to use decimal number system. We are just going to focus on binary and then how we can directly convert to octal. That's the idea here. Okay, how can we do this? Well, we have a table, okay, a table that represents the binary equivalent of octal numbers. Okay, so I'll just introduce you to the table, but actually you don't have to memorize this table. Actually, you can come up with this table. First of all, I'll just show you the table. So let's say we have octal numbers in one side, and then we have binary numbers in another side. Okay, so in octal numbers, we know there are 7 digits. Okay, so this table is going to work like an encryption. Okay, for a specific octal number, there is a specific equivalent binary number. Okay, and for a specific binary number, there is a specific octal number. So let's talk about the digits in octal. So we have 0, 1, 2, 3, 4, 5, 6, and 7. These are the 8 digits in octal number system. Okay. The special part about this is octal has the base of 8. Okay, and binary has a base of 2. Okay, so the thing is, since binary and octal are actually connected due to their powers. Okay, so we know 8 is equals to 2 to the power 3. Okay, 8 is equals to 2 to the power 3. So what happens is, if you use 3 digits of binary, if you use 3 digits of binary, you can actually come up with a pattern that can be used to represent octal numbers. Okay, so the thing is, 3 digits of binary means you are using 3 bits to represent a single octal number. So binary for octal 0, you can represent it with 3 zeros. Okay, and for 1, you can represent with 0, 0, 1. And what happens is, you're going to add 1. Okay? You are going to add 1 to each of the prior number in binary. So if you add 1 to this, you'll get 0, 1, 0. And if you add 1 to this, you'll get 0, 1, 1. Similarly, it goes on and on. Okay, so this is how you're going to use the table to come up with the answers when we are converting from octal to binary or binary to octal. Okay, so what you have to keep in mind is every single digit in octal number can be represented by using 3 digits in binary number. Okay, you don't have to memorize this. You can actually use the simple thing. So here we know the decimal equivalent is 0. Okay, the decimal equivalent is 0. The decimal equivalent is 1. The decimal equivalent is 2. The decimal equivalent is 3. The decimal equivalent is 4, and so on. Since we are focusing on only the first 7 digits, the octal equivalent is same as the decimal equivalent. Okay, so keep that in mind when you are doing this. So let's do an example to come up with the idea how we can apply this. Okay, so let's say we have an octal number that goes like this. Let's say we have 7 to the base 8. What you have to do is, for each digit, okay, for each digit, you are going to replace the digit with the binary coding that we use. We know 7 is represented by 1, 1, 1, and 2 is represented by 0, 1, 0. So the binary equivalent will be equals to 1, 1, 1, 0, 1, 0 to the base 2. You don't need the decimal translator here. Okay, you can directly write the answer down. Okay, let's do another question. Let's say we have 7, 3, 6 to the base 8. Where 7 is represented by 1, 1, 1, and 3 is represented by 0, 1, 1, and 6 is represented by 1, 1, 0. And you can write down these two. Okay, simple as that. Let's say we have something like a bigger number, 9, 4, 3. Well, we can't have 9, 4, 3 because 9 is not a digit in octal. So let's say we have 7, 7, 3, 2 to the base 8. So that will be equals to 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 1, 0 to the base 2. Okay, so how can you remember this? Well, if you see 7, well, let's just talk about this. If you see 7 to the base 10, what will you write down? So you have a 4, you have a 2, and you have a 1. will be the answer, right? You are going to do the same thing. Okay, with practice, it will just be muscle memory for you. But until that, do it like this. You don't have to memorize the number table. Okay, so let's try another number, like something like 14327 to the base 8. Well, 1 is represented by 001, 4 is represented by 100, 3 is represented by 011, 2 is represented by 010, and 7 is represented by 111 to the base 7. That's all. Here, you don't have to convert this huge number to first decimal and then convert it back to binary. You don't have to do that. Okay. So when you are converting from binary to octal, you're going to do the same thing. Okay. When you're converting from binary to octal, you're going to do the same thing. But here, we use the method called grouping. Okay. So what you have to do is you have to write down the digits in the binary number as sets of 3. Okay. As a group of 3. Okay. So let's say we have 111100 a to the base 2. What you have to do is from the rightmost point, okay, from the rightmost digit, you're going to group it by 3. So you can group it as 111100 to the base 2. Okay, and we know 111 represents 7, 100 represents 4. So it will be 74 to the base 8. That's all you have to do. So keep in mind, you're going from in this direction. Okay, you're going from this direction, not this direction. If you do that, you will make mistakes. Okay, so don't do that. Go from the rightmost digit. Okay, rightmost digit. So let's say we have 1111010101 to the base 2. Well, that will be equals to, put a comma so that you can easily understand the 3 digits. So it will be 001. You can put 2 zeros in front, right? Because they don't carry any value. So you can put 2 zeros. Nobody's gonna blame you. And then we have 111, 011, and 011 to the base 2. Well, we know 1 represents 1. This one 111 represents 7. 011 represents 3. 011 represents 3. So it will be 1733 to the base 8. 1733 to the base 8. You don't have to convert it to decimal and then convert it back to octal. Okay, pretty simple. Let's try a huge number. Okay, like 111, 011, 1 to the base 2. Well, first of all, let's break it down into groups of 3 digits. Well, then we can write it down back again so that we don't make any mistakes, just to make sure we don't have any careless mistakes. Now we know 111 represents 7, 011 represents 3, again 3, 7, and then 5 to the base 8. Okay, you can keep doing, just put some ones and zeros, and yeah, you will be good to go with different questions. It will be like fun to do. So let's divide it into threes. So here we have 3, 3, 3, 3, 3, 3, another 3. So it will be equals to 001, 110, 101, 010. Then we have 111, and then we have 011, then we have 101, finally 101 again to the base 2. Okay, so now we know this represents 1, this represents 6, then we have 5, then we have 2, 7, 3, 5, 5 to the base 8. Okay, so this is the beauty of converting from binary to octal directly. Okay, what about floating point numbers? Okay, in the last video, I didn't talk about floating point numbers when you are converting from binary to octal directly. I didn't talk about that. Well, the reason was it will be hard. Okay, it will be hard when you use the decimal as an intermediate translator to convert from binary to octal. Okay, but the beauty of this method is you can easily find the answers here also. So let's say we have a binary floating point number such that 1110.1010. Well, in this case, we have this is base to the 2. In this case, before the decimal point, we go in this direction. After the decimal point, we go in this direction. That's all you have to do. Okay, I'll put a 1 here. You have to go in this direction. So here, you group from the right to left direction. here you will group from the left to right direction. That's it. Okay, so this will be equals to 1,110.101,010. Okay, to the base 2. So that will be equals to, this one is 001, so it will be 1. 110 is 6 point, 101 is 5, and 010 is 2 to the base 8. That's all you have to do. Okay, so just try to use this method whenever you can. Okay, let's do another question on 1011.101111101. Okay, so in this direction, after the decimal point, we go in this direction. Put the 2 here. So it will be, there will be a comma here, there will be a comma here, and there will be a comma here since we are going in this direction. So this is equals to 11011.1011010 to the base 2. So this will be equals to, you can put a 0 here. So this will be equals to 33.572 to the base 8. Okay, so let's try another one. 111.011.10101010. Then here in this direction we have to go, and here we have to go in this direction. So there will be here a comma, here a comma, here a comma. We can put a 0 here, and we don't have to put a 0 here. So it will be equals to, we'll write this down directly, we don't have to write this down. So we have 7, then we have 3 dot, we have 5, then we have 2, then we have 5 again, and then again 2 to the base 8. Okay, I didn't write these questions down, and I'm not doing now. Okay, and I'm not writing, I'm not looking at a book and writing this down. I'm just writing random numbers. Okay, for my practice. You can also do the same thing. Okay, so what if we have octal numbers, floating point numbers of octal number system? Well, I'll write down an example: 47.334 to the basic. Well, you do the same thing. There is nothing new here. So 4 is represented by 100, 7 is represented by 111 point, 3 is represented by 011, 3 is represented by 011, and 4 is represented by 100. So you don't have to put the zeros here. And that's it. That's it. Pretty straightforward. Okay, so I'll write down another number. Okay, so 4, 3, 2, 1. Yeah, this works. So it will be equals to 5 will be 101, 6 will be 110, 3 will be 011, point 4 will be 100, 3 will be 011, 2 will be 010, and 1 will be 001 to the base 2. Okay, let's do the final example and we can wind up. I'll teach you how to convert from binary to hexa in the next video. Okay, because the time doesn't allow me to continue with the video, so we'll look at it in another video. For now, let's finish the final example. A big example maybe 57623.4729. No 9. We can't have 9. 3, 5 to the base 8. So that will be equals to 10111111010111011 to the base 2. Okay, just think, if I had asked you to do in the first method that I taught you in the last video, it wouldn't be easy. Definitely not easy. Okay, because this is 2 to the power minus 1, this is 2 to the power minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. It will be 1 over 1024. Just think of it. It's not the hassle. So use this method. Okay, do some practice questions on your own. If you have any doubts, let me know in the comments. We'll do a live stream to clear all the doubts. Once I get enough doubts, I'll do a live stream with 5. Yeah, so stay tuned.
Thanks for watching the 8th video in our number system series. If you found this tutorial on the grouping method for binary and octal conversions helpful, don't forget to like, share, and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master number systems and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.